So here's this one. Again, maybe pause, take a second, think about, how would you describe it in terms of rate of change and in terms of amounts of change, since I now remember that I put both of these here just a little while ago. All right, so in terms of rate of change, so now in this case, we do start right at the wall, right? If we say this is distance from the wall. So we start at the wall, and we are, as time is increasing, so as time increases, the distance from the wall is increasing, right? Because they're getting farther away from the wall. But in this situation, we'd say something like at a decreasing rate or speed, right? Whichever way you want to say it. I know I did it the other way on the last page. That would be that whole thing we talked about on the last slide that we said Usain didn't do. But right, he's slowing down. And so if we did that in terms of amounts of change, that would be saying something like, hey, every second, your distance from the wall should increase. Distance from the wall will increase. I can't spell, sorry. But we would say by smaller and smaller amounts. Right? And so that's where we did that thing where we drew, like, okay, in that second, I don't know why I had to make a straight line. In that second, you cover quite a bit of distance, right? So that right there is how much distance you cover. But then the next second, you only cover that amount of distance. So that right there, again, is the distance you cover. Then the next second, you cover even less distance. And then that final second, right, you cover even less distance. And then you have like another 2/3 of a second. So every second, right, that you cover a smaller and smaller amount of distance. That's kind of what we're looking at. So that would, again, they mean the same thing. This first one is kind of thinking about it as keeping that ratio together, right? We're talking about speed, so we're putting it together. Here, we're talking about it and we're breaking it apart. We're looking at the change in time and the change in distance separately. And then finally, for the last part, we have to kind of come back. So this last piece here, this piece, right? So if we went back to speed, we could say, okay, as time continues to increase, right? Continues to increase. Sorry. Like now the distance from the wall decreases, right? You're getting closer to the wall. But we would say at a constant rate. Or again, as some of my students might say, like you take the same size as step every second kind of idea. And so then since I'm jumping there anyway, we would say now every second, the distance from the wall decreases. Distance from wall decreases by the same amount. Right? And if that wasn't clear already, every second. Ooh, sorry. Oh no, I'm getting busy. There we go. Right? And so this would be a way, again, of communicating both rate of change where we keep it together and amounts of change where we're taking those two pieces and we're breaking it apart. Which is actually something that's really valuable to be able to do, is thinking about the ratio of the two quantities as one, or thinking about just the ratio, or sorry, the two quantities separately.